Hello and welcome to Chemistry Lesson 3.05 over ions. This is the actually the last video in this chapter that we're going to be doing. So it's kind of a shorter chapter, but we're going to talk about ions. What are they and why do we care? So an ion, the definition is an atom with a charge. Atom with a charge. And by charge, we're talking about, there's two possibilities for charge. You can have positive charge, or you could have negative charge. So we have positive and we have negative. And you kind of understand charge. Usually, most of your experience with positive and negative comes from playing with magnets, where you understand there's a positive end and there's a negative end. And if you put the positive end of one magnet to the negative end of another, they attract. But if you put two positive ends together, they repel. So we say that like charges attract and our opposite charges attract and like charges repel. Sorry about that. Let me make sure you heard that correctly. Opposites attract, like charges repel. Well, how does an atom end up with a charge? Well, we know it's not from neutrons because neutrons don't have a charge. They're neutral. So it must be from changing either the protons or the electrons. Can we change protons? And so if I take an atom of helium, can I change the protons? Hopefully by now you understand that the answer to that is no, because if I take away, if I add, gosh, what do I have? Let me grab my periodic table. All of a sudden I can't think what's on the other side of, oh yeah, if I take away an atom or a proton from helium, I get hydrogen. And if I add a proton, I get lithium. So no, I can't change the protons. So let's talk about lithium actually. And I'm going to make, I'm going to color code. So let's do, electrons will be blue, E negative, blue. Let's do protons, P plus, be a little green. And let's make neutrons black because we're not really going to do much with those. So if I take an atom of lithium 6, so we know lithium, so let's talk about lithium. And let's do lithium 6. We know lithium has 3 protons, and since it's lithium 6, we have to have 3 neutrons. Usually when we talk about elements, we assume they're neutral. So these 3 protons give me a charge of +3. So that means around the outside, and I'm not going to draw the orbits in here. Well, I will for this first one. Let me get something lighter like a ballpoint pen. So those represent orbits. Orbiting around the outside, they're actually in orbitals, we have 3 electrons. So this ends up with a -3 charge, and this has a +3 charge. And -3 plus +3 gives me an overall charge of 0. So we call that neutral. Now, don't let the neutrons fool you that this is mass. So when we talk about this, that's mass. When we talk about charge, we're talking about the total number of electrons and the total number of protons. And when they're equal, there is no charge, it's 0. But what happens is lithium always tries to get rid of one of their electrons, and you end up with, we still have 3 protons, we still have 3 neutrons, but we only have around the outside 2 electrons. So now I have a +3 in the nucleus and a -2 in my electrons, well, hopefully your algebra skills let you know that if you've got +3 and -2, that's going to give you an atom with a charge of +1. So this is now an ion. It is an atom with a charge. If the charge is positive, and I'm going to write this a different way, I'm going to say positive, we call it a cation. A cation. Get it? Positive cation. Okay, let's look at another example. Let's do fluorine. So fluorine has 9 protons, and I'm not going to, I don't want to draw it out this time. Yeah, I don't think I'm going to have room, so I'm not going to draw all 9 again. So in a normal, can't make up my mind here on my colors. Let's go with fluorine, Fluorine, fluorine. So when it's neutral, fluorine always has 9 protons. So when it's neutral, it's going to have 9 protons for a charge of +9, and it's going to have 9 electrons for a charge of -9. That adds up to 0. But here's what fluorine does. Fluorine always tries to gain electrons. It always gains 1 electron. And so instead of having 9 electrons, I have 10, which gives me a -10 for my negative charge and a +9. That means when I find what's called my net charge, when I add up my positives and negatives, I have a -1 net charge. If my ion has a negative charge, so if my charge is negative, I have what's called an anion. An anion. But you can use this trick to help you remember. Positive, cats have paws, so a cation is positive. Anions are negative. Think about if you knew somebody named Anne and she was always talking about the negative side of things. So, all right, let's do some sample problems. With protons, electrons, and net charge. So let's say sample problem number 1. Let's say copper has 28 electrons. What is the net charge? Well, to find net charge, you have to know how many protons and how many electrons you have. So when I look on my periodic table, I see that the atomic number for copper is 29. So that means it's going to have 29 protons. So it's going to have a +29 charge. It's got 28 electrons, so it's going to have a -28. That means my net charge, +29 minus 28, is going to be +1 net. All right, let's do question number 2. Calcium has a net charge of +2. How many electrons does it have? Okay, so if I look at calcium, I see that calcium always, I actually have to grab my periodic table here, has 20 protons. So it's going to have a plus 20 charge. In this case, I don't know how many electrons I have, but I know it's got a plus 2 charge. So what I have to do is I have to think, okay, what negative number added to 20 is going to give me plus 2? Well, it means I'm going to need a negative 18 because 20, positive 20 added to negative 18 is going to give me positive 2. So negative 18, or it'll have 18 electrons is the answer. All right, let's do one more. Problem 3. Let's talk about iron. No, let's see. Let me do this. An element has 46 electrons and a net charge of plus 1. What element is this? What I'd like to do is, you see me making these little banks over here to the side. So I always do my protons, electrons, and net charge. So I've got some number of protons, I don't know what. And for electrons, I have 46. So I have a negative 46. And I have an overall charge of plus 1. Well, that must mean that my positive charge has to be one larger than this. That means I have to have 47, a positive 47, to get that to work. So what they were really asking here is, in order to get plus 1, if you've got a negative charge here, what's the positive value? Well, positive 47 is what has to go there. If I have 47 protons, and I look on my periodic table, I find that I'm talking about silver. All right, so our takeaways here are we can change the number of neutrons. Those are isotopes. We can change the number of electrons, and when we do, we end up with a charge in something called an ion. That charge is positive, we have a cation. If it's negative, we have an anion. Then we can use what we know about, remember, where am I getting the number of protons? That's the atomic number. So let me just add that in as a review. The protons are the atomic number. Can I change the number of protons? No, I cannot. So I can use what I know from the periodic table, atomic numbers, and calculating, adding up a positive and a negative charges to get net charges. And I can use that to answer questions about different ions. All right, so that is our introduction to ions. Thanks for watching and have a good day.